Today we're diving into an often overlooked but absolutely critical aspect of electrical work, conduit bending. It might sound mundane, but the precision and regulations involved are significant. Rachel, why is conduit bending such a central skill for electricians?
It's fundamental, Jake, because electrical conduit runs rarely go in a straight line. Whether it's intermediate metal conduit, rigid metal conduit, or electrical metallic tubing, you're constantly encountering obstacles. You'll need to change direction for everything from simple offset set outlet boxes to complicated angular bends around columns, beams, or cornices. The skill of bending these conduits on site is what makes a neat, safe, and efficient installation possible.
So we're talking about making these changes in direction by physically bending the conduit rather than using prefabricated pieces for every turn. What kinds of tools are involved in achieving these bends?
Exactly. While factory elbows are used for larger sizes, especially for 90-degree turns, field bending is often more economical and allows for custom runs. Electricians use mechanical, hydraulic, and even electric benders. The choice depends on the conduit size and the complexity of the bend. This module specifically details how to achieve those bends using these various tools.
It sounds like there's a lot more to it than just forcing a pipe into a new shape. Are there specific rules governing how these bends must be made?
Absolutely, and these rules are critical. The National Electrical Code, or NEC, in Chapter 3, lays out precise installation requirements. For rigid metal conduit, for instance, NEC Section 344.24 mandates that bends must not damage the conduit or effectively reduce its internal diameter. This is incredibly important because a damaged or constricted conduit makes pulling electrical conductors extremely difficult and can damage their insulation.
Reduced internal diameter, damaged insulation, these sound like serious safety and functional concerns. What are the specific guidelines for preventing that? Are there minimum radius requirements?
There are very specific minimum radius requirements based on the conduit's trade size. For example, a half-inch trade size conduit needs a 4-inch radius to its center, while a 6-inch trade size conduit requires a 30-inch radius. These aren't arbitrary numbers. They're designed to ensure the integrity of the conduit and the conductors inside. If you bend too tightly, you risk kinking the conduit, which, as I mentioned, can impede wire pulling and cause insulation damage.
And that makes sense. You wouldn't want to create new problems while solving another. Beyond the radius, are there limits to how many bends you can have in a single run of conduit?
Yes, there's another crucial NEC rule here. Every change of direction adds resistance when pulling wires. So the NEC specifically states that you cannot have more than 4 quarter bends, which total 360 degrees, in any one conduit run between outlet boxes, cabinets, panels, junction boxes, or other pull points. This limit is in place to prevent excessive difficulty and potential damage during wire pulling.
4 quarter bends, or 360 degrees. That seems straightforward enough, but what exactly counts as a bend in this context? An elbow is clear, but what about smaller adjustments?
That's a great question, and it's where some electricians can make mistakes. An elbow is a standard 90-degree bend, often used in pairs to create a back-to-back bend. Then you have offsets, which are 2 equal bends used to navigate around an obstruction. Saddles are 3 or 4 bends designed to cross over another conduit or a small obstacle. And a kick is a single bend less than 90 degrees, often used in concealed work. The misconception sometimes arises that offsets, kicks, and saddles don't count towards the total bend degrees, especially if they're smaller angles.
So, are you saying that even a small kick or an offset contributes to that 360-degree limit, even if it's not a full 90-degree elbow?
Precisely. The source states, quote, offsets and saddles add just as much resistance to pulling conductors as any 90-degree elbow. A 45-degree offset, for example, takes 2 45-degree bends, which equal one 90-degree bend. A saddle may be as low as 60 degrees or as high as 180 degrees, depending on the types of bends used. End quote. Even a 15-degree kick, if you have several of them, will quickly add up and make wire pulling incredibly difficult. Every degree of bend must be included in that total count, ensuring it doesn't exceed 360 degrees.
That's a crucial clarification. It sounds like sometimes installing an additional pull box to break up a long run with many bends might be more efficient, despite the extra cost.
It often is. The additional cost of pull boxes and their installation can be offset by the labor saved in pulling conductors, especially with larger conductor sizes. It's about optimizing the overall project. And there's one final important detail for conduit bending. Don't overlook the outside diameter. While conduit measurements are based on the inside diameter for conductor capacity, the outside diameter is what determines the size of the opening it needs to pass through.
Another subtle but impactful detail. What's a practical tip for ensuring complex bends are right the first time?
When you're dealing with a really complex bend, a great tip is to test it out first using a piece of wire. Bend the wire into the shape you need, then use that bent wire as a template. It's a simple way to confirm your measurements and angles before you start bending expensive conduit, saving time and materials.
That's an excellent, practical piece of advice. Understanding the NEC requirements, the different types of bends, and these practical considerations truly elevates conduit bending from a simple task to a skilled craft. This conversation certainly highlights the detailed knowledge required in electrical installations.
It truly does. Every detail, from the minimum radius to the total degrees of bend per run, plays a vital role in the safety and functionality of an electrical system.
If you found this discussion insightful, consider sharing it with someone who might also benefit from understanding the intricacies of conduit bending.